Hello, dear students. I am glad to meet you at our course. Today we are going to discuss steel for construction. Let's start. Ever since the late 1800s, when the first skyscrapers were erected in Chicago, steel continues to be a primary building material. Buildings, especially commercial projects, used cast iron. However, steel gradually replaced cast iron as the former was more structurally sound and fire-resistant. Thereafter, steel became a crucial component in the construction business. Steel is an alloy of iron and carbon containing less than 2% carbon and 1% manganese and small amounts of silicon, phosphorus, sulfur, and oxygen. Steel is the world's most important engineering and construction material. It is used in every aspect of our lives, in cars and construction products, refrigerators and washing machines, cargo ships and surgical scalpels. Common types of steel used in buildings: carbon steel or mild steel, rebar steel, structural steel. Different types of structural steel shape: custom shapes, T-shaped, bearing pile, H-shaped, channel, C-shaped, angle, L-shaped, pipe, I-beam, hollow steel section, HSS. Steel is produced via two main routes: the blast furnace basic oxygen furnace (BF-BOF) route and the electric arc furnace (EAF) route. Variations and combinations of production routes also exist. The key difference between the routes is the type of raw materials they consume. For the BF-BOF route, these are predominantly iron ore, coal, and recycled steel, while the EAF route produces steel using mainly recycled steel and electricity. Depending on the plant configuration and availability of recycled steel, other sources of metallic iron, such as direct reduced iron (DRI) or hot metal, can also be used in the EAF route. A British inventor, Henry Bessemer, is generally credited with the invention of the first technique to mass-produce steel in the mid-1850s. Steel is still produced using technology based on the Bessemer process of blowing air through molten pig iron to oxidize the material and separate impurities. Steel is becoming popular in residential construction. Earlier, designers and architects picked wood over steel, especially for framing applications. However, with wood framing, durability was an issue, so many professionals started using steel instead. Structural steel is often used alongside concrete to create impressive and long-lasting buildings. Its versatility, sustainability, and flexibility are some of the main reasons for its use, as well as being a very cost-effective material. With a high strength-to-weight ratio, steel can often provide a solution where other materials are unsuitable. Let's look at some of these advantages: flexibility and adaptability. Long-span steel sections can be used to create large, open spaces which can be easily adapted, making them extremely flexible in terms of use. These spaces can be divided in easily using temporary or flexible partition solutions and changed later with minimal cost, demolition, and disruption as the requirements of the building change. Steel is tensile. It has a high strength-to-weight ratio, which means it has high strength per unit mass. So no matter how large the overall structure is, the steel sections will be small and lightweight, unlike other building materials. Steel is very durable. Structural steel structures can withstand external pressures such as earthquakes, thunderstorms, and cyclones. A well-built steel structure can last up to 30 years if maintained well. Sustainability. Steel has several environmental benefits, such as being 100% recyclable. In the United Kingdom, the estimated recovery rate of recycled steel from steel structures is 96%, and globally recycled steel accounts for 50% of new steel production. Speed of construction. One of the main reasons for choosing structural steel is the speed of construction, especially where disruption to nearby roads and buildings can be an issue. Disadvantages of structural steel structures are: steel is an alloy of iron. This makes it susceptible to corrosion. This problem can be solved to some extent using anti-corrosion applications. It has high maintenance costs as it has to be painted to make it corrosion resistant. There are extensive fireproofing costs involved as steel is not fireproof. In high temperatures, steel loses its properties. Buckling is an issue with steel structures. As the length of the steel column increases, the chances of buckling also increases. Steel has a high expansion rate with changing temperatures. This can be detrimental to the overall structure. Poor insulation. Therefore, to make your building energy efficient, you will need additional insulation, which will counteract the conductive nature of steel. The possibilities for using steel in buildings and infrastructure are limitless. The most common applications are listed below. For buildings, structural sections, reinforcing bars, sheet products, non-structural steel, heating and cooling equipment, and interior ducting, internal fixtures and fittings, rails, shelving, and stairs. For infrastructure, transport networks, bridges, tunnels, rail track, fueling stations, train stations, ports and airports, utilities, underground pipelines to distribute water to and from housing, and to distribute gas, rebar for power stations and pumping houses. Thank you for your attention, dear students. Next time we are going to talk about glass as a construction material. See you next time. Goodbye.